The continuous assignment statement. This is the formal name for the assign statement. It consists of the keyword assign, space, a net, the equal to symbol, and an expression terminated with a semicolon. An important aspect of the assign statement is that you can only make assignments to net types, and in our case that means the wire type. The expression on the right hand side is like a normal expression you'd have seen in other languages. It consists of operators and operands, and the operands can be a mix of wires or reg variables, constants, function calls, or parameters. So for the moment you can just think of the operands as being of type wire or of type reg. The operation of the assign statement during simulation is that any change to any of the operands on the right hand side will cause the expression to be re-evaluated, and the result of that expression is then assigned to net. So as we noted before, the expression is used to drive a value onto the wire. During a simulation, the expression is sensitive to any changes in its operands, which in turn can drive a new value onto the wire on the left hand side. Another language component that's important for us is the initial construct, and an example is shown with this code. It consists of the initial keyword followed by a statement, and normally we want to group a number of statements together as part of the initial construct, and to do that you use a begin and end with the statements grouped between them, and this constitutes what's known as a block. In Verilog, a begin and end with statements in between is known as a block. During simulation, the initial statement executes starting at time t is equal to 0. The notion of time is important for simulation in Verilog. The first statement in our block is an assignment statement. Now this is formally known as a procedural assignment statement, and it's different from the assign statement or continuous assign statement we had on the previous slide. With procedural assignment statements, the left hand side will be of type reg and cannot be of type wire. So to use a wire on the left hand side of an assignment inside an initial will result in a syntax error. So we can only make assignments to reg variables. Here we have another assignment. This time we're updating into, which must be of type reg. The next statement we have starts with what's known as a delay control. In Verilog, the hash followed by a number, and that can be an integer or a real number, constitutes a delay control. So our first delay control is #1, and the purpose of the delay control during simulation is to force a delay before the execution of the code that follows it. So we've got #1 that indicates wait for one time unit and then execute the statement that follows it. And this is a display statement which outputs information to a command window. After the execution of this display, we encounter another delay control, #8. Again, this indicates a delay of 8 time units before executing the statement that comes after it. And in our example, that means that the in1 = 1 assignment will occur 9 time units after the start of the initial construct, and so on for the remaining statements. During the simulation, the initial construct starts at time 0 and sequentially executes the code following the order in which the statements are listed. So this statement will always execute before the next statement, and the statements execute in the order listed. When the simulation gets to the end of the block, the initial construct is finished and there's nothing else left to do. The main idea in terms of understanding the initial construct is that the statements execute sequentially in the order specified. As noted, the #delay, where delay is an integer or real value, is a form of timing control, and it's usually found in test bench code. For our work this semester, Do not use the initial construct within design modules. Its primary purpose is to initialize values for use in a test bench. If needed, it's okay to use 2 or more initial constructs within a test bench, and we'll see some examples in later segments. A common requirement with test benches is to generate test signals that we can use to test our design modules. Let's say we have 2 reg variables, A and B, and we want to generate a waveform such as the one shown here. To generate this waveform, we can use an initial construct. We start with the keyword initial, and we use a blocked in to group a number of statements together following the initial, and the block begins with the keyword begin. Our first assignment, we set A is equal to 0. This occurs at time t is equal to 0. B is set equal to 0 at the same time. And you can see here at t is equal to 0, we've set A and B both to 0. The next change occurs at time t is equal to 3. So in order to effect this, we need to wait 3 time units before executing the statement B is equal to 1. And when we do that, B changes from 0 to 1 at time t is equal to 3. There is no change to A, it remains at 0. Our next change occurs at t is equal to 6. In order to effect this within our initial construct, we note that at t is equal to 6, it's 3 time units from our last change. So we need to wait 3 time units from our last change before we change B back to 0. Assignment B is equal to 0 occurs at t is equal to 6. And in a similar way, when we want to change A to 1 at time t is equal to 7.5, we're at time t is equal to 6 here, so we wait 1.5 time units and then change A to 1, and that will affect this change. This brings us up to the time t is equal to 7.5 time units, and if we enter a final delay control of 2.5 followed by the null statement, so we don't have anything to do after this time, that'll bring us up to the time t is equal to 10, and ending our initial construct now gives us the waveform shown in the figure. In summary, a module is the main building block in Verilog. The module definition is the creation of the module, and the module instantiation is the use of the module in which a copy is made and connections are made to the module ports. A design module models functionality, and in our example, some simple logic gates. And the test bench module is used to test our design module. Wire and reg types were introduced, and we covered the way in which they are used, in particular when making connections during instantiations. Hierarchy is used as a way to handle complexity. The continuous assignment will model functionality in our design modules, and the initial construct is used in test bench modules, using a delay control to provide test stimuli.